So hi, good afternoon, everyone. So today we're going to continue to look into normal distribution graphs. And I am purposely doing this subtopic very slowly because I think it's very important for you to know the connection, okay, hubungan di antara binomial distribution and normal distribution, and why actually normal distribution is very, very important. Okay, it's very, very important for us to understand. Okay, so Monday's class and today's class kan dia macam style kuliah di universiti lah. Okay, and very little examples, macam kamu mendengar sajalah, no, kau tidak banyak membuat latihan. Maybe kalau kamu ada, kamu menyalin saja. Okay, but my purpose is to give you a very good basic of normal distribution graphs, so that when we start with the calculation, you have all these things in your head sudah lah. Hopefully lah. Okay, all the important characteristics about the normal distribution graphs, you should know them so that it is easy for you to answer the questions when the time comes. Okay, so in my previous class, I gave you 4 very important characteristics, okay, of normal distribution graphs. Okay, and these 4 are very, very fundamental to what we're going to talk about today. Can somebody please give me the first one?
Bell curve.
Okay, very good. Nampak sangat yang kita berlakon. Okay, bell curve. Okay, and so the bell curve will be shaped like this lah. Sometimes the bell curve can be a very high bell, or sometimes it can be a very low and spread out bell. Okay, dia jarang ada high and spread out lah. It's very jarang. Usually it's high and nipis atau low and fat. Okay, usually that's the case lah. Okay, the second characteristic of the normal distribution graph.
The mean is in the middle.
The mean is in the middle. Very good. Okay, the center of the curve, okay, equals to the mean. So no matter what your value is, okay, no matter whether kamu punya R, remember your binomial in the graph, right? This is the probability and this is the values of R, 0, 1, 2, 3, 4, 5 until n lah. So no matter what your value of the R is, no matter how small or how big, and especially today we're going to talk about big R values, okay? The center of the curve, paling tengah, okay, always represents the value of the mean R. What am I doing? Okay, sorry. The center of the curve, okay, always represents the mean, okay? And this is still R, okay, macam when we spoke about this in binomial, R is from 0 until second lah. Okay, so the center of it now is always the mean, the purata, the average value of the R's, okay, the number of trials. Okay, third characteristic. What is so important about the standard deviation?
If it's bigger, it's more flatter.
Okay. So standard deviation tells you the size of the distribution. Okay, so if it is a big standard deviation, okay, and if it is a small standard deviation, you are going to get a different kind of bell curve. Okay, can you tell me between the tall and thin and then the short and fat one, which one is the big standard deviation, which one is the small standard deviation?
The big one is the flatter one.
The big one is the flatter one. Betul-betul semua orang mengharap Yong. Okay, so this one is big standard deviation. Okay, manakala this one is small standard deviation. Okay, these are all very important ciri-ciri lah. So big one, the curve will look very flat in this one. The small one will look very tall and very thin. But whether it is short and fat or tall and thin, the point is still the same. The center of the curve, okay, always is the mean. Center of the curve always is the mean. Okay, now there are situations where big standard deviation is good and there are situations where small standard deviation is good. Big standard deviation means perbezaan antara orang yang pertama dan yang terakhir adalah sangat besar. Ada banyak perbezaan lah. Okay, manakala if the standard deviation is very small, everybody is about the same. Okay, sedikit dia punya perbezaan. Big standard deviation means besar dia punya perbezaan. For example, the mass of the people in 5ST. Okay, GSIM budak di 5ST. I think will have a very big standard deviation. Ada orang yang kecil-kecil kan baru 30 kilogram macam Eva. Ada orang yang besar-besar macam Yong kan baru how heavy are you? Let's say 70 kilograms lah. So it's kind of a big gap. Okay. Tetapi a small standard deviation will be something like markah admit peperiksaan pertengahan tahun kelas 5 ST. Small standard deviation. Sebab paling kecil, contoh paling kecil maybe 40, paling besar 60. Okay, so everybody is about this, small standard deviation lah. So dia punya perbezaan sangat kecil. Okay, big standard deviation means paling kecil lah maybe 12 kg lah. Paling besar maybe 100 kg macam tu. So it's a very big standard deviation. So dia punya taburan memang lebih besar. Okay, so the standard deviation tells us the kind of graph, the size of the graph, and whether there is a lot of difference among the data that is given to you. And this helps us, especially like macam guru-guru bahkan, ini banyak membantu kami untuk mengetahui apakah strategi seterusnya. For example if I'm in a class, okay, honestly, I would say that markah admit pelajar 5ST kan is a big standard deviation. Sebab ada yang markahnya sangat sikit dan ada yang markahnya sangat tinggi. Okay, so there's a very big difference between the weak students and the not so weak, the strong students lah. Okay, and this helps me because I know that, saya mau tengok how many strong students are there. What is the probability of stronger students? Which one has the bigger probability? Kalau kebarangkalian murid yang lemah adalah lebih besar, then I know that I have to use a different strategy. Tetapi kalau markah kamu macam tiada beza lah, paling kecil is paling sikit markah 40, paling tinggi markah pun 60. So it is in that way I have to teach your class in a different manner. Sebab kamu punya level kan hampir sama ni, 40 to 60. There is not much difference between the super smart one and the super not so smart one. Okay, sorry, the highest mark and the lowest mark. Tidak banyak beza. Okay, so that one will help us when we analyze kan, that will help us to know what is the next step to take. And a lot of people in the business world, in the design world, in the world of statistics, they use this information very importantly. Adakah perbezaan pendapat sangat besar? Atau adakah perbezaan pendapat sangat sikit? Kalau perbezaan pendapat sangat sikit, apa langkah seterusnya? Kalau perbezaan pendapat sangat besar, if there are many people that don't agree compared to the people that agree, what is the next strategy? Okay, so a standard deviation is a very important indicator to us. Okay, what is the last and the final characteristic of the normal distribution graph? Oh, yes, funders gave already. Normal distribution graph is written as the random variable, okay, is normally distributed. X is always a random variable. We started this chapter by talking about two different kinds of random variables, which is discrete random variable and continuous random variable. Okay, tetapi random variable selalu diwakili oleh huruf X. So X is the random variable that is normally distributed, and dalam normal distribution, the two most important numbers are the mean and bukan standard deviation funders tetapi variance. Okay, not standard deviation. Now, although standard deviation is important to us lah, tetapi dari segi notasi, we want the variance. Okay, beza daripada binomial lah. Binomial, what are the two important numbers? The random variable is binomially distributed, and the two numbers that we need are how many altogether and the probability of success for one. Okay, so these are very important, apa yang kita panggil notations. Okay, distribution notations. Astaga, distribution. Okay, distribution notations. Normal, the two numbers here represent the mean and the variance. Binomial, the two numbers here represent the n and the probability of success. Okay, so tidak boleh campur aduk. You need to know what distribution you are involved in. And then when you know what distribution, then you must set it in your mind. Okay, kalau binomial, saya hanya perlu n dan p. Kalau normal, saya hanya perlu mean dan variance. Daripada variance, I can calculate the standard deviation. Okay, so today, the first thing that I want you to do for the next 20 minutes, okay, is to do this activity in page 169. Okay, this is a very important activity. Open your textbooks to page 169, and if you have your coin with you, it's good to have your coin now. Okay, I want to go through this activity with you, and then I'm going to give you about 20 minutes to complete it. So, number one, prepare a coin and construct a table as shown. So what you do is you do a table, okay, where n and then the outcome, okay, the outcome sama ada H atau T lah. Head is kepala and T is ekor. Number number is tails and picture is heads. Okay, kita set and then the third column, what you do is you do a cumulative trial, okay, of getting H. Okay, cumulative trial mean of getting H okay, which is a head. Kita mau peristiwa kita mendapat kepala. Okay, so this is an example. Let's say the first time kamu lambung, okay, kamu dapat H. Okay, so kalau letak H di sini lah. So setakat ini berapa sudah head kamu dapat? Okay, it is 1/1 sebab baru kali pertama kamu this one. Kali kedua kamu lambung, okay, dalam contoh kamu dapat tail. Did you get a head here? No. So that means it's 1/2. So ini kali kedua sudah kamu cuba. Okay, tapi setakat ini baru satu kali yang kamu dapat kepala. Okay, number 3 you get heads. So setakat ini 1, 2 sudah kepala kau dapat, per berapa sudah cubaan? 3. Okay, and do it for 30 times. Okay, I want you to do this for 30 times. Do you understand, guys? Do you understand how to calculate this? Nombor di bawah adalah sama dengan nombor n. Okay, nombor yang di atas ini adalah setakat ini berapa sudah kepala yang kamu dapat. Kalau kau tidak dapat kepala, then the number will be the same lah. If you get a kepala, then you tambah 1. Okay, so let's say the next one, let's say yang keempat, kamu dapat kepala. Okay, so what is my number on top? My number on top will be 1, 2, 3 heads over how many trials? 4. Macam tu. Okay, and then all your answers, give it to me in decimal places. Okay, so 1/2 will be 0.5, this will be 0.667, this will be 0.75, dan seterusnya. Okay, I want you to do this 30 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. 30 kali saja, bukan saya suruh kamu buat 300 kali. Okay, can you do it now please? Do it now. Put it in a table or something like that. Okay, ini table saya akan minta ini ya. So yeah, please draw a nice table because I want to see the table. Write your name on top. Okay, Raudatun, Syifa, apa-apa. Okay. 5ST. Okay, ini saya akan kira sebagai kehadiran kamu hari ini ya. So make sure you do this table now. Okay, I give you 20 minutes. Actually 15 lah. I give you 15 minutes to complete this table. Okay, do it now. Anybody got any questions? Anything you don't understand? Do the table first, then we will answer the questions together. Okay. Okay. I'm going to use, somebody send me their answers. So I'm going to use this set of answers. Okay. What I want you to do is take a look at the pattern. Okay. Look at the pattern of this answer. Later you look at your answer. Keep your answers, people. Okay. Because this is going to be your work today. Okay. Keep your answers. Okay. But let's take a look at this set of answer and let's take a look at this analysis. Turn to page 170 in your textbook. Okay. Can I start? You guys okay?
Can.
Can
Yes,
okay.
sir.
All right. So let's take a look at what happens So in this particular set, you will probably not get the exact same. Okay, but I want you to take a look at the pattern. Okay, let's take a look at question number 5A. Okay, and obviously the answers to these questions, you are going to need it so listen very carefully. Okay, A, what happens to the mean value when the number of trials increases? That means this mean prime over here. Take a look at this pattern. The more trials you do, okay, apa yang terjadi kepada nilai mean ini? Anybody?
Decrease.
Okay, one is it decrease. It seems to be decreasing kan. At first it's 1 and then ada sedikit increase here, 0.5 to 0.67, 0.75, 0.6, and then decrease, and then naik lagi balik. Okay, and then by we find that the more your number of trials, okay, the bigger the number of trials, okay, we find that actually the value of the mean seems to stabilize. Okay, the value of experimental mean lah. Okay, the value of the experimental mean, okay, which is mu prime, okay, seems to be stabilizing. So the value of the, okay, decreases and what is a better word for stabilizing? Oh, okay, and becomes more constant. Okay, dia bukan sentiasa constant lah, tetapi kita tengok, look at the pattern especially from trial number 17 all the way to trial number 30. It seems to be hovering around the same number, 0.4, 0.4, 0.4, 0.4, maybe the last one is 0.5 lah. Okay, but we see this happening, you know. The first few tries, the first 10 or the first 15 kan, dia macam a little bit unstable. Sekejap 0.7, sekejap 0.6, sekejap 0.5. But you find that the more your number of trials, makin banyak cubaan yang kamu buat, okay, you will find that it is gravitating toward a certain number. Dia seperti dia macam, after a while kan you can guess sudah by ni. Okay, so this is the answer for question number 1. Okay, question number B. Question B. It is known that the theoretical mean value of mu is 0.5. Okay, logically, this one you have been taught since maths. Okay, bila kamu lambung duit shilling, apakah kebarang kalian mendapat kepala atau ekor? You know that the answer is 0.5 because we have been taught this. Okay, but itu adalah theoretical value kalau satu kali saja kamu lambung. Kan? The theoretical value is always, you know, depending on the situation, but for flipping a coin, it's always 0.5, the theoretical value. Okay, so look at the question. Is the experimental mean value approaching the theoretical mean value of 0.5? So you take a look at your numbers. Okay, is this number approaching the value of 0.5 or is it not? Okay, and depending on your own coin, okay, some of you will get the answer yes and some of you will get the answer no. In this particular example, the answer seems to be yes because finally at 30 dia sudahlah dia ngam-ngam 0.5. Okay, but you take a look daripada 18 all the way to 30, right? Dia macam sekejap turun, then lepas itu naik, then makin lama makin dia naik balik 0.4, 0.46, 0.48, and then finally 0.5. So some of you will get the answer, yes, it is approaching the theoretical mean value. Some of you will get no, it is not approaching. Tetapi kalau dia not approaching kan, dia tidak terlalu jauh lah. Okay, by right, you should, okay, this is a very perfect answer lah. Okay, fortunately for this person who did this, this is a very perfect answer. When I did this, as I did kan, makin lama kan, my final value was about 0.44. This was my final value. Okay, so it is, yes, correct. It is definitely near to the experimental mean, but it is a little bit tersasar. Okay, it is a little bit tersasar daripada experimental mean. So look at your own data. Okay, look at your own data. Jangan juga kamu menyalin data ini ya. Okay, look at your own data and make your own conclusion. Is it approaching the experimental mean? Kalau yes, yes lah. Okay. Kalau tidak, sorry, theoretical mean. Kalau tidak, okay, then tell me whether dia tersasar lebih daripada theoretical mean atau kurang daripada theoretical mean. Okay, listen carefully. I'm giving you the answer for B. Okay, I just want you to think about this for yourself. Look at your own data. Okay, tell me whether your value, according, menurut kamu punya tanggapan lah. Okay, according to your your pemerhatian, adakah nilai itu approaching the theoretical mean of 0.5? Okay, is it getting nearer and nearer to 0.5 atau adakah dia makin tersasar? Okay, if it is makin mendekati, then okay lah, good lah, just say. But if it is makin tersasar, then you may need to give a possible reason why dia tersasar. And this is, for me, I think this is more fun lah. For example, mine is 0.44, a little bit tersasar. Okay, and so there are many reasons for this. Okay, there are many reasons for this, and any reason can actually be, as long as it is logical, okay, any reason I will actually accept any reason. Okay, but I want you to think of why is it, how come when I do, my value gets bigger and bigger, gets further and further away from the theoretical mean. Okay, tapi saya rasa kebanyakan daripada kamu akan menghampiri theoretical mean lah, so I wouldn't worry about it. Okay, question C. Now, from the table, draw the graph of the means of the experiment against the number of experiments. So this is the graph that you're going to look at now. I want you to, something like this. Okay, it's going to be a long graph. So you draw 1, 2, 3, 4, 5, all the way until 30. Okay, and then if I look at this, nombor paling besar is 1, nombor paling kecil is 0.42 maybe. Okay, 0.42. This one you have to, this one you kind of have to do this one. So you do 0.1, 0.2, 0.3, all the way until 1. Okay, then setiap satu kamu plot, dan kamu sambung saja. Ini bukan best fit, nothing to do with best fit. Okay, let's say kamu punya titik-titik macam ni, bahkan astaga, sorry. Okay, so kamu sambung sajalah. Let's say this is 1. Okay, sambung saja macam ni. Okay, draw a nice looking curve. Okay, just do like that. Okay, then on the same graph, draw a straight line to represent the theoretical mean. So change color of your pen or use another color. Okay, we know that the theoretical value is 0.5. So 0.5 over here, I want you to draw a straight line like this, all the way until 30. Okay, and then answer question D. Based on this graph, compare the experimental value and the mean value that you got. Okay, obtained after 30 trials with the theoretical mean value. I just want you to compare. Okay, and for this question, soalan D, you can actually Google. I would suggest that you Google to see how people write this comparison. Okay, I Google, okay, what you can do, you Google this law of large numbers, okay, in coin flipping. Okay, jangan juga kamu tengok yang dice punya lah. Okay, Google this one, law of large numbers in coin flipping, to see what is the lesson behind today's activity. Apakah pengajaran di sebalik aktiviti ini hari? Okay, there's a reason why I want you to discover this for yourself. Okay, and I will tell you this at the end of the chapter, but this needs to be done. Everybody needs to do this. Okay? Any questions? So, first of all, in your sheet of paper, make sure kamu masukkan jadual ini. Okay, sorry, jadual mengikut muka surat 169 lah, page 169. Secondly, draw the graph of the probability against the number of trials. Sorry, the mu prime, okay, against the number of trials. And then kamu sambung lah. Okay, you are not going to get a straight line. If you get a straight line, means you're cheating. Okay, it's going to be a very weird looking graph, and you can Google this to see whether your graph is the same as the graph in Google. Okay, trust me, this is a mathematical certainty lah. Okay, your graph should look about the same. Sepatutnya graph kamu itu bentuknya hampir sama. Don't forget to draw the theoretical value so that you can answer question D. The only question you need to answer is question A, question B, and question D. And question A is what happens to the mean. Okay, B is the experimental mean value approaching the theoretical mean value. And then D, compare this graph and this graph. Okay, and to get the answer for question D, pergilah Google ini dan tengok macam mana diorang jawab. Okay, actually your textbook also got the answer one. Okay, your textbook also got the answer, but I also want you to go and search lah. The textbook doesn't have the answer for the graph, but the textbook has the answers for question D. Like you can also refer to that if you want.